Okay, welcome back. This is chapter 14 from Giancoli, example 3. What we've got here is a hot frying pan that was left in the oven, and we've got some water in a sink that we're going to try and cool it down with. Now, in the textbook or in the examples, sometimes it makes you want to check to make sure it doesn't boil off all the water and then you have a phase transition. But let's just assume that the water doesn't get all boiled off and we just want to find the final temperature. Now, if the final temperature is above 100 degrees, we know it did boil off, but let's just see what happens if we assume it doesn't. So what we've got is, we've got this mass of iron, and we've got this mass of water, and they said in here, assume the mass of water is roughly the same as the mass of the frying pan. And what we've got, so this is the iron or the frying pan, heat going from here to here, so that this has a tempered initial of 200 degrees. This has an initial temperature, let's just assume around room temperature, so 20 degrees Celsius. And this is degrees Celsius too. And this has a specific heat of water. Let's see if we can solve for the final temperature when they're both at the same temperature. And that's the equilibrium that we're looking for. Okay, so in general, we know that the heat that gets released is going to be the mass times the specific heat times the change in temperature. So let's do that for each of these and make them equal. So for the iron, what do we have? We've got the mass of the iron times the specific heat of the iron, and we can find it right here, right? It's 450. Times its temperature change, which is 200 degrees C, minus T final. Okay, and what's the heat that goes into here? Well, that's going to be the mass of the iron, because they're going to be about the same. Specific heat of the water times, what do we have? T final minus the 20 degrees. Right, that's how much it was heated up. Now, you'll notice that the masses cancel, so we don't have to worry about those anymore. Let's multiply these out, and what we want to find is get T final by itself. So I've got 200 degrees times Ci minus T final times Ci equals the specific heat of the water times the final temperature minus 20 degrees C water. Okay, now we're going to collect, we want to get this TF by itself, so we're going to move this one over and move this one over here. So what do we get? We get 200 degrees, the specific heat of the iron, plus 20 degrees times the specific heat of the water, equals, now this is T finals moving over, so it's going to be common. We're going to T final onto CW plus Ci, the specific heat of the water, and that. So now we can solve for the final temperature is going to be 200 degrees Celsius times the specific heat of the iron plus 20 degrees Celsius times specific heat of the water divided by the sum of those specific heats. So let's just, and what we've got, we know that seawater is 4186 per kilogram, joules per kilogram, degree C. And what do we have for iron is 450. 200, we know all of this. Okay, let's do the calculation here. So we got 200 times 450, and we got 20 times 4186. Add those up and then divide by 4186 plus 450. Divide that, and you find that the final temperature, let's go roughly, 3747, and we for sure only have 2 sig figs. I mean, that's really 1 sig fig, but let's say we have 2 sig figs. Final temperature is 37 degrees, and you'll notice that's much less than 100, so this kind of makes sense for our calculation. So our final temperature is 37. Now, why, if this thing was 200 degrees and it only dropped to there, why didn't the water boil off and all that? Well, the specific heat of water is about 10 times as much for iron. So if we had 10 times as much iron, then we could start getting into something more interesting. But because we had the same amount of each, the water just heats up a little bit.